I love to read solutions that are super creative. I think maybe there's a misconception that we're interested in really high level mathematics, and sometimes simplistic models are the best. So if I see that one quantity increases as another quantity increases, maybe directly proportional, maybe some sort of linear relationship is appropriate. It doesn't have to be some high level mathematics that makes it happen. It needs to be something that is relevant and creative.
What I like to see is first a description of the problem and then develop the model. I like to see first the expressions they use and explanations of the equations, why they chose that, and then with their assumptions, are they reasonable? Did they justify them? Did they support them either through data or through some research? I like to see them get to the point, explain, justify, answer their problem.
I have a hard time with papers that there's an equation and there's no explanation of where the equation comes from or what they were thinking when they wrote it. So for me, it's not just about, what was the mathematics, but what were you thinking and why did you come up with that? What data did you look at that helped you draw that conclusion, or what were you missing in data and said we had to make a reasonable assumption, so we decided to choose this, and here's what the results are.
Things I don't like to see are first just equations standing by themselves, because if they don't carry with them an explanation, then I begin to question, well, did they just lift this from somewhere? Do they really understand what they're doing?
I have a hard time with grammar that's incorrect, so it really needs to be proofread.
The good papers, the references are complete, the graphs are there, they've mastered sort of the text and math formatting, and very few typos in the paper, so they've done the proofreading.
I love it when students come up with the most interesting stuff that I never would have thought of. Students are often coming up with ways to incorporate sort of current data. I think those are really, really cool solutions. Teams that are thinking about competing in the challenge should take a look at the website. There's lots of information there. So there's past questions. Now we have thought of the month. That gives you the opportunity to look at some more interesting and timely questions, which are always good for preparing for the challenge. There's a math modeling handbook on the website that they should take a look at. So those are all good resources.
It's very impressive that in 14 hours, here's a nice 20-page paper, introduction, the model, the conclusions, the recommendations, the shortcomings. So it's very impressive that they accomplished that in the limited time that they're given.